Today we're checking out DLSS 4 in Unreal Engine 5. I'll show you how to set it up, how it looks in-game, how it works in the movie render queue, and we'll compare the quality side by side. In case you're new to it, DLSS stands for Deep Learning Super Sampling. It's basically NVIDIA's AI trick to boost performance while still keeping things looking sharp. First, open your favorite browser and search for DLSS 4 for Unreal Engine. Then, click on the first link. It should take you straight to NVIDIA's developer page. Now you'll see a Download Now button. Go ahead and click it. Here you'll find download links for multiple Unreal Engine versions. Since I'm using Unreal Engine 5.6, I'll download that one. Just pick the version that matches your engine. I'm not sure why, but this pop-up always shows up blank. Just ignore it and click Accept. The download should start right away. If you're using IDM like I am, just click Start Download Again to begin. Once the file is downloaded, I'll move it to my desktop to show you the next steps. First, we need to extract it. You can use WinRAR or 7-zip for that. Now open the extracted folder, go to the Plugins folder, and copy all the plugins from there. Next, I'll open a new File Explorer window and go to the Unreal Engine installation directory. In Local Disk C, go to Program Files. Then open the Epic Games folder. Inside, choose the folder that matches your Unreal Engine version. Open the Engine folder, then go to the Plugins folder. Inside, look for the Runtime folder. Open it, create a new folder called DLSS, and paste all the plugins into it. Now go back to the first File Explorer window. Open the Samples folder, then go into the Plugins folder. Copy the plugin from here and paste it into the DLSS folder we just created. Now we can close the DLSS folder window, but keep the other File Explorer open. Next, open the Epic Games launcher and head over to your library. Choose your game project in the library, right-click on it, and select Show in Folder. Now open the Content folder and copy the Blueprints folder from the NVIDIA sample project into your game project's Content folder. I had to replace the files because I've done this before. But if you're copying them for the first time, you won't see that prompt. Now finally, we can launch the game project. Once the project is open, go to the top menu. Click on Edit and then select Plugins. In the search bar, type NVIDIA and enable all the plugins that I'm enabling in this video. These are the plugins we need to enable. Once you've done that, just click Restart Now to apply the changes. Now we can close the Plugins window and go ahead and open our game level. I'm using the Valley of the Ancient project, which is a sample project you can download and use to test all of this yourself. Now let me show you how you can test DLSS in your game before fully implementing it. Now click on the 3 dots button and select Open Level Blueprint. I've got the Valley of the Ancient level blueprint open here. If you already have some nodes in your graph, don't worry. We're just going to add a few more to set up DLSS. Now right-click anywhere on the graph and search for Get Player Controller. Next, right-click again and search for Create Widget. Then connect the return value from Get Player Controller to the owning player input on the Create Widget node. Click on the Class dropdown, search for BPW_NGX, and select it to add to the node. And make sure to connect your earlier nodes to the widget node since everything is running from the Event Begin Play node. Now drag from the return value pin on the widget node and select Promote to Variable. Name this variable DLSS and hit Enter to save it. Now drag the blue pin from the DLSS variable node and search for Add to Viewport. This will display the NVIDIA DLSS overlay in your game so you can test it. If you want, you can change the Z order to 1 or 2 to make sure the overlay appears on top. But in my case, leaving it at 0 still brings it to the front. Everything looks good so far, but we need to add one more node to make sure we can interact with both the game and the UI at the same time. Now drag from the return value pin on the player controller node and search for Set Input Mode Game and UI. Now let's clean things up a bit by adjusting the position of this node to organize the graph. Then, connect the output from the Add to Viewport node to the new node we just created. Also, connect the DLSS variable to the InWidget to Focus input on the Set Input Mode Game and UI node. That's it. Everything's set up. Now just click Compile and then Save to finish the blueprint. To launch the game, click on the three dots next to the Platforms button, then select Standalone Game. This will launch your game in a separate window. Next time, you won't need to do this. Just click the Play button and it'll automatically open in standalone mode. This might take a little time. It really depends on the size of your project and your system specs. And here we have the DLSS UI running in our game. You can toggle it with the H key, as shown on the screen. Since we added the Game and UI input mode in the level blueprint, we can play the game and interact with the DLSS UI at the same time. The character is working fine, but I forgot to add the node that lets the cursor move freely over the UI. I'll show you how to fix that in a bit. First, let me show you how these DLSS settings actually affect the game. I can still select options with the hidden cursor, but it's not ideal. Once you select a setting on the UI, the cursor might become visible, but it can disappear again. So first, let's switch the resolution to 2K so the game runs in full screen. If you're using a 4K monitor, feel free to set the resolution to 4K as well. Now let's move on to the next setting, NVIDIA DLSS. By default, it's set to Auto, but you can switch it to any mode, like Ultra Performance. Honestly, this is one of the reasons game developers don't even bother optimizing games anymore. Anyway, after setting it to Ultra Performance, you might not notice a big visual difference right away. So let me enable the NVIDIA Game Overlay so we can see the FPS and actually measure how DLSS boosts performance. Each DLSS mode makes a big difference to the game. Quality improves the visual fidelity, while the performance modes focus on boosting your FPS. I'm not sure why, but the auto mode doesn't make much of a difference. But when I switch to Ultra Performance, the FPS jumps from 120 to 190, which is a solid boost. Now let's turn off DLSS and move on to DLSS frame generation. Just a heads up, FrameGen is only supported on NVIDIA's 40 and 50 series GPUs. So if you're using an older card, this feature won't be available for you. Frame generation won't work without DLSS, so make sure DLSS is enabled. You can also check the Show Developer DLSS Frame Gen Stats option to display stats directly on the UI. It even updates FPS faster than the NVIDIA overlay. Setting DLSS Frame Gen to Auto works just fine, and if we switch the DLSS mode to Ultra Performance, we get a massive FPS boost. Next we have NVIDIA Reflex. It says it's supported, but it's currently grayed out because the game is running in windowed mode. To use it, we need to switch to full screen mode. But I don't know why, whenever I switch to full screen mode, my OBS stopped recording the game. So I can't show you that in video, but it works really good. Next up is Dynamic Vibrance mode. Let's turn it on and try adjusting the values to see if it actually makes a difference. The difference is pretty clear in the game viewport. You can also use the saturation boost for even more impact. Just make sure your Dynamic Vibrance intensity value isn't set to 0 or it won't work. I hope you've got a good idea of how DLSS works in-game. Now let me show you how you can use DLSS for your renders. I'm using a different project for this part, but you can use any project you like. Go to Edit and open Plugins again. This time, search for Movie Render Queue, and you'll see a DLSS plugin specifically for it. Enable it, and if the engine asks you to restart, go ahead and do that. Now open the Movie Render Queue and go into the config. If you already have a preset, go ahead and load it. But if you want to copy my settings, check out my previous video where I walk through everything. I'm not going to render in EXR or MP4 this time. I'm also going to remove the color output settings to avoid getting dark-looking renders. Now click the plus button and add DLSS/DLAA to the config. Also, add PNG sequence to the config. Now go into the DLSS settings and change the DLSS quality from performance to quality. All the DLSS modes work the same way here as they did in the game. One thing to note, Ultra Quality mode doesn't work in the Movie Render Queue yet. Hopefully, NVIDIA will enable it in future updates so we can get even higher quality renders. You can also use DLAA instead of DLSS, both for rendering and in games. But keep in mind, DLAA focuses purely on image quality. It doesn't give you any performance boost like DLSS does, so while it can look sharper, it's not ideal if you're trying to improve FPS or rendering speed. Personally, I prefer DLSS quality mode over DLAA. I've tested it multiple times, and DLSS consistently gives better looking renders than DLAA. Now I'll choose the render location on my desktop, where I already have a DLSS folder set up. Now I'll start the render. It should only take a few seconds since I'm rendering just 6 frames. After that, I'll render the same scene without DLSS so we can compare the quality side by side. Now I'll remove DLSS/DLAA from the config, change the output folder, and start the render again. Both renders are done, so now let's close the Movie Render Queue and Unreal Engine. I've got the render folder right here on my desktop. I'm going to open the first frame from both renders so we can compare them. Now, if you've got a sharp eye, or the eyes of a beholder, you'll notice the difference in shadow quality and the details on the tree leaves right away. Watch my mouse cursor and try to spot the quality differences, especially in the finer details. You might think the difference isn't huge, but that's the point. When used right, DLSS gives you faster renders with high quality. For example, you can go for 8K renders, and DLSS will help speed it up while still looking better than the default settings. Right here in this spot, the DLSS render has less noise and better color compared to Unreal Engine's default anti-aliasing. And if you still can't see the difference, it might be time for a new pair of eyes. I hope you guys learned something new from this video. I'm aiming for at least 20,000 views and 1,457 likes in the next 2 weeks. So hit that like button if this helped you out. I also posted on the channel asking if you wanted me to cover more in this video, but I didn't get any requests for extra workflows. So this is it for now. If you've got questions about DLSS, or if you're just wishing CS2 had better anti-cheat, I'm all ears. Unfortunately, Garbin isn't.